In this lesson, we're going to talk about nth term of geometric sequence. Bago natin i-discuss ang pag-solve ng nth term of geometric sequence, recall muna tayo about geometric sequence. So, paano nga ba natin malalaman kung ang isang sequence ay geometric or hindi? So, para malaman kung geometric siya, dapat meron tayong makukuhang common ratio or isang number na iminumultiply sa isang term para makuha yung susunod na term. So, check natin ang example na to. Yung 3, 5, 7, 9 at saka 11 nga ba ay geometric sequence. I-check natin. So, medyo mabagal ang pag-increase. Try natin mag-subtract muna. So, 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. And 11 minus 9 is 2. So, since may common difference tayo, hindi ito geometric sequence. Ito ay arithmetic sequence. So, this is not a geometric sequence. Next, example, we have 5, negative 10, 20, tsaka negative 40. So, dito medyo mabilis yung pag-increase niya. So, check natin kung may common ratio nga ba. Divide natin. Negative 10 divided by 5 is negative 2. 20 divided by negative 10 is negative 2. Negative 40 divided by 20 is negative 2. So, since may common ratio tayo, masasabi natin na ito ay isang geometric sequence. Next, let's have 7 raised to negative 1, 7 raised to 0, 7 raised to 1, 7 raised to 2, and so on. Ito nga ba ay geometric sequence? Yes, ito ay geometric sequence. Since naka-exponential form tayo, at pag sinabi nating exponent, kagaya nito na 2, ang ating exponent, siya ang magsasabi na ita-times natin ang 7 ng 2 beses sa sarili niya. So, since nagmumultiply lang naman tayo sa sarili niya, ibig sabihin, ito ay geometric sequence kasi ang ating common ratio ay 7 or yung base niya mismo. So, it means this is geometric sequence. Next, let's have the last example. 3, 5, 9, 17. So, try natin muna i-verify kung geometric siya by dividing the second term sa first term. 5 divided by 3 ay 5 over 3. 9 divided by 5 ay 9 over 5. So, since magkaiba sila ng quotient, yung 5 over 3 is not equal to 9 over 5, this is not geometric sequence. Hindi rin to arithmetic sequence kasi kung i-verify mo, 5 minus 3, that is 2, 9 minus 5, that is 4. So, kitang-kita na hindi common ang kanilang difference. So, it is also not a an arithmetic sequence. So, this is not a geometric sequence also. Let's consider the sequence 2, 6, 18, 54, and so on. How do we get the next term in this sequence? So, to get the next term of this sequence, we need to check the common ratio. 6 divided by 2 is 3. 18 divided by 6 is also 3. 54 divided by 18 is also 3. So, ibig sabihin, to get the next term, we need to multiply 3 from the previous term to get the next term. So, what is the fifth term? So, para makuha yung fifth term, ita-times natin yung 54 sa 3 dahil pang-apat na term na ang 54. So, 54 times 3, that is equal to 162. And then next, how about the sixth term? So, same process ulit, yung 162 naman ang ita-times natin sa 3, which is equal to 486. To illustrate further the given sequence na 2, 6, 18, and 54, isusulat natin siya in terms of a sub 1 times r. So, sa first term na 2, iti-times natin siya sa common ratio na 3. Pero ang exponent niya ay 0. So, parang baliwala lang din siya kasi 3 raised to 0 is equal to 1. Kaya 2 times 1 is equal to 2. Yung a sub 2 naman, na 6, ay nag-times lang tayo ng r, which is 3 raised to 1. So, isa lang yung exponent niya, kaya 2 times 3, that is equal to 6. Yung third term naman, na 18, naging dalawa na yung exponent ng ating common ratio. So, 3 times 3 is 9, times 2 is 18. Sa fourth term na 54, naging 3 na ang ating exponent. So, 3 times 3 is 9. 9 times 3 is 27. Then, 27 times 2 is equal to 54. And then, sa fifth term, nadagdagan ulit ng isang exponent, yung 3, kaya naging 162. At ang sixth term, nadagdagan ulit ng isa pang exponent, yung common ratio na 3, kaya naging raised to 5. And ang term na ay naging 486. So, pansinin natin yung exponent ng ating common ratio. Starting from 0, padagdag siya ng padagdag ng isa. Kapag ikukumpara siya dun sa n, or yung position ng term, nagbabawas ng isa yung exponent ng common ratio. So, kapag first term ang ating hinahanap, ang common ratio natin ay may exponent na 0. Kapag ang second term ang hinahanap, ang common ratio natin ay may exponent na 1. So, ibig sabihin, from the number of term or yung position ng ating term, para makuha yung exponent ng r, magbabawas lang tayo ng isa. So, let's say 6 term ang hinahanap, ang exponent ng ating common ratio ay 5. Since bawasan lang natin ng isa ang 6, magiging 5. So, sa madaling sabi, to describe the rule of the sequence, magiging 2 times 3 raised to n minus 1. Yung a sub n, or yung value ng n, ang magiging basis natin dun sa exponent ng ating common ratio. Magbabawas lang tayo ng isa. Ibig sabihin, base sa pag-analyze natin, ang formula for n term of geometric sequence ay a sub n is equal to a sub 1 times r raised to n minus 1. Wherein, ang a sub 1 is the first term. Ang a sub n ang ating last term, yung r ang common ratio, at ang n ang number of position of terms. Number or position of terms. So, sa madaling sabi, kapag sinabing hanapin ang 8th term, ang magiging value ng n is 8. In the sequence 5, 15, 45, 135, and so on, ang first term natin ay 5. And then, ang common ratio natin ay 3. Kasi 15 divided by 5 is 3. 45 divided by 15 is 3. 135 divided by 45 is also 3. So, to get the next term, nagmumultiply lang tayo ng 3 sa previous term. So, ibig sabihin, from the nth term or yung nth formula of a geometric sequence na a sub n is equal to a sub 1 r raised to n minus 1, we can describe this sequence in following the nth rule na a sub n is equal to 5 times 3 raised to n minus 1. Papalitan mo lang yung a sub 1 ng 5 at yung r ng 3. And then, copy lang yung value ng n. Pero pag meron na tayong hahanapin na nth term, yung n ay kailangan na nating palitan. Let's try to solve some problems. What is the 7th term of the sequence 1, 3, 9, 27, and so on? So, since 7th term ang hinahanap, ang value ng n natin ay 7. Una, i-identify muna natin ang a sub 1 or ang first term. Ang first term ay 1. Tapos, ang common ratio, 3 divided by 1 is 3. 9 divided by 3 is also 3. 27 divided by 9 is also 3. So, ibig sabihin, ang common ratio natin ay 3. So, from the nth term formula na a sub n is equal to a sub 1 times r raised to n minus 1, papalitan natin ngayon yung value ng a sub 1 na 1 at saka yung r na 3. So, ang ating nth rule dito sa sequence na to ay a sub n is equal to 1 times 3 raised to n minus 1. At dahil kailangan natin malaman ang ating 7th term, papalitan na ngayon natin ang value ng n natin, which is 7. So, a sub 7 is equal to 1 times 3 raised to 7 minus 1. And then, simplify natin yung 7 minus 1, that will be 6. So, isi-simplify na ngayon natin yung 3 raised to 6. Yung 3 raised to 6, ibig sabihin nito, ita-times natin yung 3 ng 6 na beses sa sarili niya. So, that is 3 times 3 equals 9. Tapos, 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. At pang-anim, 243 times 3, that is equal to 729. So, ang 3 raised to 6 ay 729. Kapag tinimes mo siya sa 1, ang sagot pa rin ay 729. So, sa madaling sabi, ang ating a sub 7 or ang 7th term natin ay 729. Let's have our next problem. What is the 8th term of the sequence? 8, 4, 2, 1, and so on. So, since decreasing naman ang ating sequence, possible na ang ating common ratio ay fraction or less than 1. So, identify muna natin ang a sub 1 or first term. Ang a sub 1 natin ay 8 dahil siya yung nauna. And then, ang common ratio natin, second term divided by first term or 4 divided by 8, that is equal to 1/2. Kasi ilo-lowest term lang natin tong 4 over 8 by using the greatest common factor na 4. So, 4 divided by 4 is 1, 8 divided by 4 is 2. Kaya 1/2 ang ating common ratio. We can also solve using 2 divided by 4. So, 2 divided by 4 by using the greatest common factor na 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So, same lang siya. 1/2 ang ating common ratio. And then, from the nth term formula na a sub n is equal to a sub 1 times r raised to n minus 1, we can now have the nth term rule na a sub n is equal to 8 times 1/2 raised to n minus 1. Palitan lang natin yung value na a sub 1 na 8 at yung value ng r natin na 1/2. So, from the nth term formula na a sub n is equal to 8 times 1/2 raised to n minus 1, palitan na natin ngayon ang value ng n, which is 8 kasi 8th term ang hinahanap natin. So, that will be a sub 8 is equal to 8 times 1/2 raised to 8 minus 1. And then, simplify natin tong 8 minus 1, that is 7. So, since na fraction ng ating base, i-distribute lang natin yung exponent both sa numerator and denominator. So, magiging 1 raised to 7 over 2 raised to 7. And saan naman nanggaling yung 2 raised to 3? Yung 2 raised to 3 ay nanggaling sa 8. Kapag ginawa nating exponential form ang 8, magiging 2 raised to 3 siya. Dahil kapag minultiply mo ang 2 ng 3 times by itself, ang magiging sagot ay 8. Kaya pagka kinonvert mo yung 8 sa exponential form, that is 2 raised to 3. So, bakit ako nag-exponential form? Kasi, para masanay tayo later on, naggamitin ang exponential form, lalo na kapag sinusolve ang value ng n. And then, isimplify lang natin. So, magiging 2 raised to 3 times 1 over 2 raised to 7. Kasi yung 1 raised to 7 kanina, ang magiging answer ay 1. And then, since this is a whole number, gawin natin siyang fraction. Lagyan natin siya ng denominator na 1 kasi automatic pag whole number, ang denominator niya ay 1. And then multiply numerator to numerator and denominator to denominator. So 2 raised to 3 times 1 is 2 raised to 3. And then 1 times 2 raised to 7 is 2 raised to 7. So dahil naka-quotient rule tayo dito or sa paggamit ng ating law of exponent na quotient rule, kailangan lang isubtract yung kanilang exponent. So para mas mabilis, kapag nag-subtract ka, i-check mo lang kung saan mas mataas yung exponent. Doon mo ilalagay yung magiging answer dun sa subtraction. So, 7 minus 3, that is equal to 4. So, since ang 7 ay nasa denominator, which is mas mataas kesa 3, ilagay natin siya sa denominator. And then, simplify na natin ngayon yung 2 raised to 4. So, 2 raised to 4 is equal to 16. Dahil 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So, 4 na beses nating minultiply yung 2 sa sarili niya. Kaya, ang ating a sub 8 ay 1 over 16. Okay, proceed tayo sa next example. What is the sixth term of the sequence 8, 12, 18? So, since medyo increasing siya, ang ating common ratio dito ay greater than 1. So, check natin. Ang first term ay 8. Tapos, ang common ratio natin ay a sub 2 divided by a sub 1 or 12 divided by 8. That is equal to 3 over 2. Or pag nilowest term mo yung 12 over 8 using greatest common factor na 4, that is equal to 3 over 2. Or you can also use 18 divided by 12. That is a sub 3 divided by a sub 2. And then, pag nilowest term mo siya, using greatest common factor na 6, 18 divided by 6 is 3, and 12 divided by 6 is 2. So, ang ating common ratio dito ay 3 over 2. And then, from our nth term formula, we can now have the nth term rule na a sub n is equal to 8 multiplied by 3 over 2 raised to n minus 1. So, from the nth rule na a sub n is equal to 8 times 3 over 2 raised to n minus 1, palitan na natin ngayon yung value ng n, which is 6 dahil 6 term ang ating hinahanap. So, that is a sub 6 is equal to 8 times 3 over 2 raised to 6 minus 1. And 6 minus 1 is 5. So, we have now 3 over 2 raised to 5. So, dahil ulit naka-fraction ng ating base, i-distribute natin tong exponent na 5 sa numerator at saka denominator. So, magiging 3 raised to 5 over 2 raised to 5. And same process ulit, yung 8 gagawin nating exponential form, magiging 2 raised to 3. So, from a sub 6 is equal to 2 raised to 3 times 3 raised to 5 over 2 raised to 5, lagyan natin ng denominator ulit yung 2 raised to 3 na 1, and then multiply numerator to numerator, denominator to denominator. So, magiging 2 raised to 3 times 3 raised to 5 all over 2 raised to 5. So, dito, using quotient rule, yung 2 raised to 3 lang at saka 2 raised to 5 ang pwede nating isubtract yung exponent dahil sila lang ay may same basis. So, pag ginuha natin yung kanilang difference, sa denominator na tayo magsusubtract kasi mas mataas yung 5. So, 5 minus 3, that is equal to 2. So, sa baba ulit yung answer natin dahil yung 5 ay nasa denominator. Magiging 3 raised to 5 over 2 raised to 2. So, since mapapansin natin na magkaiba sila ng bases, hindi na tayo pwede pang mag-simplify. I-multiply na lang natin or expand na lang natin yung 3 raised to 5 over 2 raised to 2. So, 3 raised to 5, that will be 243 at 2 raised to 2 is 4. So, ang a sub 6 natin ay 243 over 4. Let's have the next example. A sub 3 is equal to 32, a sub 5 equals 128, and we need to find a sub 1 and the common ratio. So, since mapapansin natin dito na medyo magkalayo yung term na given, hindi natin pwedeng makuha agad yung common ratio sa pag-divide nitong dalawang to. So, gagamit tayo ngayon ng isang formula, yung n minus k root of a sub n over a sub k. So, ano nga ba ang value ng a sub n tsaka a sub k? Ang a sub k, yan yung unang term na binanggit o yung mas mababang term na binanggit dun sa problem. So, mas nauna ang a sub 3 kesa a sub 5. So, ang a sub k natin ang a sub 3, which is equal to 32. So, ang value ng k natin is 3. Yung a sub n naman natin is the a sub 5, which is 128. So, ang value ng n is equal to 5. So, substitute lang natin from the formula. Magiging 5 minus 3 yung kanyang index. And then, yung a sub n over a sub k, that is 128 over 32. So, again, kailangan natin siyang gawing exponential form. Yung 128, gagawin natin siyang base 2. Same with 32, gawing base 2. So, para makuha yon, mag-divide lang kayo continuously by 2. So, yung 128, pag dinivide natin continuously by 2, makakakuha tayo ng 7 2 para ang maging sagot ay 128. Sa 32 naman ay 5 beses nating imumultiply yung 2 sa sarili niya. And then, simplify yung index na 5 minus 3, that is 2. So, dito, hindi na natin isusulat yung 2 kasi square root automatic ang index ay 2. And then, using the quotient rule ulit ng lowes of exponent, isubtract na natin yung kanilang exponent since parehas naman sila ng base. So, 7 minus 5, that is equal to 2. So, 2 raised to 2, or ano ang square root ng 2 raised to 2? So, madali na lang siya. Ika-cancel mo na lang yung square root at saka exponent since parehas naman sila na ang value ay 2. So, ang final answer is 2. Pero hindi lang 2. It should be positive or negative 2. Dahil ang index natin ay even. So, based dun sa rule ng radicals, kapag ang index ay positive or even rather, ang answer natin ay it's either positive or negative number. So, ang common ratio natin dito ay 2 or positive and negative 2. Since na-solve na natin kanina yung value ng common ratio na positive or negative 2, we can now proceed sa pag-solve ng ating a sub 1. Sa pag-solve ng a sub 1, meron tayong 4 alternative ways. Simulan natin sa unang solusyon. Using the n term na a sub n is equal to a sub 1 times r raised to n minus 1, gamitin natin yung a sub 3 sa pag-solve ng a sub 1. Yung a sub 3 natin, ang kanyang nth rule ay a sub 1 times r raised to 3 minus 1 dahil third term siya. So, palitan natin yung value ng a sub 3 which is 32. So, yung 32 ang ipapalit natin dito sa left side and then yung r na 2. Gamitin muna natin yung positive 2. And then, simplify lang natin. 3 minus 1 is equal to 2. So, magiging 2 raised to 2 na dito sa may common ratio. And then, yung 32, gawin natin siyang ulit exponential form. So, that is 2 raised to 5. And then, para ma-isolate natin yung a sub 1, or para ma-solve natin to remove 2 raised to 2, magdi-divide both sides tayo by 2 raised to 2. Para ma-cancel natin yung 2 raised to 2 dito sa right side. And then, dito sa left side, 2 raised to 5 divided by 2 raised to 2. So, since parehas sila ng base, we can now subtract their exponent. So, 5 minus 2 is 3. And yung final answer natin sa a sub 1 is 2 raised to 3 or that is equal to 8. So, dito sa solution na to, ang value ng r na ginamit natin ay 2 at saka yung term na a sub 3. Another alternative solution ay paggamit ng negative na value ng r, which is negative 2. So again, with the use of a sub 3 is equal to a sub 1 times r raised to 3 minus 1, we can now substitute the value of r na negative 2. So again, yung a sub 3, that is 32. And then, simplify lang ulit yung 3 minus 1, that is 2. And then, simplify negative 2 raised to 2 or negative 2 times negative 2, that is equal to positive 4. And then, divide both sides by 4. So, makakancel na natin yung 4 dito sa right side. Matitira na lang yung a sub 1. And then, dito sa left side, 32 divided by 4, that is equal to 8. So, it means, ang a sub 1 pa rin natin, dito sa second alternative solution, ay 8. Okay, proceed naman tayo sa third alternative solution sa pag-solve ng a sub 1. This time naman, gagamit tayo ng positive na r at saka yung a sub 5 sa pag-solve ng ating a sub 1. So, gamitin naman natin ngayon ang nth rule ng a sub 5, which is a sub 5 is equal to a sub 1 r raised to 5 minus 1. So, substitute lang natin yung value ng a sub 5 at saka yung positive na value ng r. So, a sub 5 is equal to 128, tapos yung r natin na positive 2. Then, simplify, 5 minus 1, magiging 4 na ang exponent ng 2 natin. And then, yung 128, gawin ulit natin exponential form, that is 2 raised to 7. And then, remove natin. Para ma-remove natin yung 2 raised to 4 dito sa right side, magdi-divide both sides tayo by 2 raised to 4. So, makakancel na yung 2 raised to 4 dito sa right side. Dito naman sa left side, madi-divide siya sa 2 raised to 4. And then, since pares ulit sila ng base, we can now subtract their exponent. So, 7 minus 4, that is equal to 3. So, ang final answer, ang a sub 1 natin ay 2 raised to 3 or that is equal to 8. Ito ang ating third alternative solution. Ang atin namang fourth alternative solution ay paggamit pa rin ng a sub 5 pero ang r naman natin this time ay negative 2 na. So, substitute ulit, yung r naman ay magiging negative 2. And then, yung a sub 5 pa rin na 128. So, 5 minus 1, that is equal to 4. And then, negative 2 raised to 4, that is equal to positive 16. And then, to remove 16 dito sa right side, divide both sides by 16. So, makakancel na yung 16 dito. And then, 128 divided by 16, that is equal to 8. So, again, 8 pa rin ang nakuha natin. So, dun sa apat na alternative solutions, pwede ka lang mamili ng isa. Depende sa'yo kung saan ka mas madaling makakapag-solve ng value ng a sub 1. Or, dun ka sa mas maliit na number. Like dito, sa a sub 3 is equal to 32. Mas maliit ang number na 32 compared sa 128. So, if I were you, gamitin mo yung mas mababang term sa pag-solve ng a sub 1. Let's have the next problem. So, dun sa una kanina, nakapag-solve na tayo ng a sub n. Sumunod, nag-solve tayo ng a sub 1 at saka value ng r. So, ano pa kaya yung pwedeng maging missing sa geometric sequence para ma-solve natin? Let's have this example. In the geometric sequence 6, 12, 24, 48, which term is 768? So, which term yung tanong dito? So, ibig sabihin, yung term number ang nawawala. Hindi natin alam kung pang ilang term ang 768. So, sa madaling sabi, may given tayo na a sub 1 na 6, a sub n na 768 dahil siya yung last term, pero hindi natin alam kung pang ilang term siya. So, ang nawawala this time ay n. So, from the sequence, masosolve din natin yung value ng r. 12 divided by 6, that is equal to 2. Or 24 divided by 12, that is also 2. Ang common ratio natin dito ay 2. So, from the n term formula, we can solve for the value of n. Yung a sub n is equal to a sub 1 times r raised to n minus 1. Kunin natin ang nth rule sa pag-substitute. Yung a sub n ay 768, a sub 1 is 6, tapos yung value ng r ay 2 raised to n minus 1. So, kung mapapansin, ang variable natin ay n, and that is an exponent. So, from the sequence or from the equation na 7, let's have the last example. In the geometric sequence 2, 6, 18, which term is 118,098? So, same process kanina or same given dun sa last example, yung 118,098 ay hahanapin natin kung pang ilang term siya. So, sa madaling sabi, ang value ng n ulit ang nawawala. So, meron tayong given na a sub 1 which is 2, a sub n na 118,098 at we need to find the value of n. And then of course, ang ating common ratio ay 3 dahil 6 divided by 2 is 3 and 18 divided by 6 is also 3. So from the n term formula, we can solve for n. Yung a sub n is equal to a sub 1 times r raised to n minus 1 pa rin ang gagamitin. So substitute lang, a sub n is 118,098 is equal to yung a sub 1 na 2, tapos yung r na 3 raised to n minus 1. And then, in this equation, we need to solve for the value of n. So, from the given equation na 118,098 is equal to 2 times 3 raised to n minus 1, pwede na natin ngayon i-solve yung value ng n. So, una, i-isolate natin yung 3 raised to n minus 1 by dividing both sides by 2. So, i-divide both sides by 2. That is equal to 118,098 divided by 2. Dito makakancel na yung 2. Mawawala na siya. So, 118,098 divided by 2, that is equal to 59,049 is equal to 3 raised to n minus 1. So, same case ulit, kailangan magkaroon tayo ng base 3 dito sa left side natin. So, gawin nating base 3 yung 59,049. I-divide natin continuously yung 59,049 sa 3 para malaman natin kung ilang 3 ang dapat i-multiply para makuha or masolve ang 59,049. So, pag ginawa mo yun, makakakuha ka ng exponent na 10. So, ibig sabihin, 10 beses mong ita-times yung 3 sa sarili niya para makakuha ng 59,049. So, dito, dahil same basis na tayo ulit, we can now use the power property of equality. So, pag same base, automatic yung exponent are equal. So, meron na tayong bagong equation na 10 is equal to n minus 1. And then, to solve for n, transpose lang natin yung negative 1 sa left side. That will be positive. So, 10 plus 1 is equal to n. And ang value ng n natin is 11. So, ibig sabihin, yung 118,098 ay pang 11 term nung given na sequence.